The Indian Association of Structural Engineers, also known as CSIR-CRRI, was conceptualized and constituted in the year 2002 by a group of senior professional structural engineers from all over the country. CSIR-CRRI is registered under the Societies Registration Act 21 of 1860. CSIR-CRRI is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural engineering fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, CSIR-CRRI has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Shri Kumar Ghosh, late Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Manoj Mittal, Professor R. Pradeep Kumar, and Shri Alok Bhaumik as its president. CSIR-CRRI is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, CSIR-CRRI has collaboration with various international professional like-minded associations and institutions like CSIR-CRRI, UK and FIB for strengthening global connections and professional exchange. CSIR-CRRI's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. CSIR-CRRI endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. CSIR-CRRI is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs. Seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. CSIR-CRRI's activities are widely appreciated and known for quality technical contents. CSIR-CRRI is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines, monthly newsletter, and Crossfall, a unique quarterly newsletter that confidentially reports structural failures and the lessons learned from them. CSIR-CRRI's publications are becoming popular with time. CSIR-CRRI has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, CSIR-CRRI started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. Reaffirming its commitment to professional excellence, CSIR-CRRI launched the accreditation program in 2023. This flagship initiative empowers practicing engineers to evaluate their competencies, identify growth opportunities, and strengthen the foundation for sustained professional success. CSIR-CRRI is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. Joining CSIR-CRRI offers exclusive resources, mentorship, and networking with industry leaders. Members enjoy discounted registration for workshops, seminars, and events, along with discounted membership of FIB, opportunities for certification, career guidance, leadership roles, and enhanced professional recognition. CSIR-CRRI has its student chapters in several leading engineering institutions as well. Membership of CSIR-CRRI is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about CSIR-CRRI is available on its website www.isstructi.co.in.
My voice is audible, Vikas?
Yes, sir.
Dear friends, welcome to the webinar. Today, the speaker is Dr. Lakshmy Parameswaran, and the topic is design principles and performance of concrete chimneys. About Dr. Lakshmy Parameswaran, she is former chief scientist at CSIR-CRRI, is an eminent structural engineer with extensive expertise of over 4 decades in the analysis, design, wind tunnel testing, and evaluation of reinforced cement concrete chimneys, cooling towers, microwave towers, bridges, including cable stay bridges. Dr. Lakshmi holds a PhD in civil engineering from IIT Roorkee. She is a recipient of prestigious awards and fellowships like Voice Cast Fellowship from Department of Science and Technology. She is a recipient of ING IABSC Best Paper Award and several other awards from institutional engineers. She is a member of various Indian Road Congress and BIS committees and significantly contributed to the drafting of various important codes of practices. She has contributed significantly to advanced structural assessment and carried out many consulting projects across the country. Now, about the topic, as you said, the topic is design principles and performance of concrete chimneys. The tall concrete chimneys continue to play a critical role in the thermal power plants, industrial process facilities, cement plant, refineries, and waste to energy projects. Although the number of new construction has declined in some regions, increasing demand for life extension, structural assessment, retrofitting, and compliance with current design standards have made engineering aspects regarding chimneys a specialized area regarding a sound understanding of structural mechanics, wind engineering, seismic behavior, durability, and construction technologies. This webinar would provide comprehensive overview of the structural design, philosophy, and performance of tall concrete chimneys, with particular emphasis of provision of IS 4988 2015 and guidelines in CICIND Model Code 2011, ACI 307-08, and relevant European procedures. Now I request Dr. Parameswaran to please continue the proceeding.
Thank you, Dr. Dhawan sir, for the nice introduction. And also I thank Vikas for preparing a nice background it covers, I think, everything what I want to speak. Thank you very much for that.
Thank you.
I hope you can see my slide.
Yes.
Yes. Yes.
And a little background for this particular topic, because this is one area where I started my work in 1987. So when Dr. Dhawan asked me to give a talk, I thought that why don't I go back and revise myself with what is happening in this area. So I prepared for this concrete chimneys, design principles and performance. In fact, during the first 10 years of my career, I have developed some software for the analysis, especially the dynamic analysis, and also based on IS 4998 1992 for a long wind and a crosswind analysis of chimneys, and also carried out internal testing of many, I would say, some of the thermal power plants of that time, like Panandro, Kutch, then Gandhinagar thermal power plant, Vanakpuri, Akrimota, and all. But then when I was looking into whether they are still there or not, I found that some of these thermal power plants, they have retired. Then I thought that it is not that human beings are getting retired after attaining certain age, but also these structures. And some of them, they started like demolishing it, but then I think now they have thinking of extending the life of these chimneys, etc., by retrofitting methods. So that gave me the interest to go through, okay, what has happened to that standards which I have used earlier, and I thought that I will share this knowledge with all of you. So as you all know that industrial chimneys, they are critical infrastructure components, and they are basically for the dispersion of the pollutants at a greater height, so that the concentration level is managed, so that the health is not affected, the public health is protected. And they are there in thermal power plants, petroleum refineries, cement manufacturing units, steel plants, and also some chemical and process industries, fertilizer industries, etc. And they are essential operational role by maintaining the draft condition that supports stable combustion and continuous industrial process, because you cannot stop the process of the plant. So that's why they play a vital role. And when we talk about the evolution, you can see that the earlier stacks, they were of low height, and basically for the emission dispersion, and the material which was used for the construction is the steel stack. But the steel stacks actually, they were having some certain problems, in the sense that the low height is one issue. One is the wind-induced vibration, another is the fatigue, then the maintenance issue because of the corrosion, etc. So, and for the design of these stacks, actually the emissions, wind and seismic forces were considered. So that then there was a transition to the reinforced concrete. And I remember the chimneys which I have tested, they were probably 120 meter, 190 meter, like that. And many of the thermal power plants, they were having unequal height chimneys, and also like maybe they are in a group, but they, because of the limitation of funds, etc., probably first they will construct one and another one after certain years, but the planning was done earlier. So with reinforced concrete, like we are able to achieve an increased height and also improve durability, and definitely they have a better wind resistance. So again, like we have to consider this wind, then the issues related to the flue gases, their composition, to consider the aspect related to the durability, the wind and seismic. Actually, the tall chimneys, they are wind sensitive structures. So most of the cases, the wind that is governing the design. Then like now, if you see the earlier chimneys, as I said, there were single flue chimneys, but then like there were some multi-flue chimneys also with two flues or three flues like that. That also we tested. And then like now, like there is another composite chimney, and there like you have a liner which may be of steel, or even now the FRP is also used as a liner material, and they are excellent with respect to the high emission control. There, the thermal stress management, that is an additional thing which one has to see. And if you see the CSIR model code for chimneys, like they have come with the chimney with concrete chimney with steel liner, FRP liner, etc. So there is advancement with respect to the material and also with respect to the height. Actually, the height, why it is important, I will tell you in my next slide. But if you see that they can be classified with respect to the construction material and functional configuration. So the RCC concrete chimneys, they can have, they can be unlined or with liners, that is with liners. Then composite chimneys, that is concrete shell with steel or FRP liners. Then multi-flue chimney, that is there is a shell, outer shell, and there are 2 or 3 flues inside, internal flues there. And steel chimneys, they can be self-supporting, or they can be also provided with some guy wires at multiple levels, so that like they are made stable with respect to the wind forces. Then the hybrid system, that is a concrete base with a steel upper section. So these are some of the, based on the construction material or how they are attached, like whether it is a self-supporting or is a guide one. So we can classify them. So again, like if you see the classification, as I said, that the reinforced concrete chimney, steel chimney, and lined or composite chimney. And height classification, basically there are short, medium, and tall. And why that tall chimneys are required? Basically, in the case of chimneys, apart from the structural design considerations, the environmental regulatory compliance, that is very important. So in India, CPCB, that basically decides, okay, what should be the height of the chimney. So now they have fixed it as 275 meter for some of the thermal power plants. So like you need up to 60, like short can be 60 to 120 medium, and about that, like the tall chimneys can be. And generally, like it can be either uniform, but to save material, generally they are given with a tapered profile. And as I said that the power plant chimneys, they have high emission dispersion and multiple liners. And process industry, there like basically we have to think more about the chemical resistance and the thermal durability, because some of the processing industry, the flue gas temperature that goes high as 400 degree also. Then the multi-flue chimney, that is shared shell, which is serving multiple units. So small industries, probably you will see 50 to 100 meter. cement plants 100 to 150 meter, power plants, as I said, that like something like 275 meter, that is what now CEA, Central Electricity Authority, they have fixed the height as, and supercritical plants even more than that. So this is the height criteria. So then I was just thinking how much installed capacity is there, and how many chimneys will be there. But I am surprised that there is not a single database of chimneys existing. But what I can see is that the power generation from fossil fuel, that is about 45%, that is from the fossil fuel, and non-fossil fuel is 54% now. So that's why I said maybe chimneys may not be required in the future, but that is not the case because we have something like 201 operational coal and lignite-based thermal power plant, and there are some 400 to 500 major power generation stations, and something like 1400 RC chimneys are there, and their height is something like 220 to 275 meter height. And at present, something like 26, basically, even the centrally funded projects are there, some state funded projects are there, even private sector is also making this power plant. So 26 active construction projects are there, and some of the projects, they got delayed, and totally something like 46 construction projects are ongoing constructions are happening now. So that means that the topic is relevant. So the challenges, as I said, that the environmental compliance, that is one major issue apart from the structural safety, durability, and economic feasibility. So basically the regulatory agencies like CPCB, they mandate what should be the height and exit velocities, and what is the dispersion criteria, and what is the limit value of the ground level pollutant concentrations, etc. So that has to be met with. And basically the regulatory requirements that influence what should be the chimney geometry, how many flues have to be there, how they have to be arranged, and the internal flow characteristics. So basically the interaction between the environmental design parameters and structural requirements, that often leads to a complexity in the design. Basically, what will happen, the environmental compliance, they will say that you have to go to 275 or 300 meter high. Then that will be more susceptible to the dynamic wind effects. So with more height, the construction cost will increase, as well as it will be more sensitive to the dynamic effects. So that is why some challenges are there in this particular case. So during the design, basically being a tall structure, we have to first see that that is stable against overturning, buckling, and the resonance, because it's a dynamically sensitive structure. So I will talk about the resonance also. Then it should have the adequate strength under the design loads. Then what is the deflection limit or drift for the serviceability and operability? Then the thermal stresses, they are also very important. So the thermal gradients and how, whether any restraints are there, then what stresses are being developed. Then, as I said, that the durability consideration is very important, because corrosion, erosion, and chemical attack, some acid attack, that can also be there. So we have to see all these aspects when we are doing the chimney design. So when you talk about its behavior, basically you can see that it is a thin shell and it's a hollow cantilever, it's fixed at the base. And as I said, that it has a tapered configuration. So the variable thickness it will have, the shell will have a variable thickness along the height. And because of the self-weight, it is subjected to axial compression. Then, as I said, that the inner temperature is quite high and outside temperature is low. So there is a temperature gradient which is developing across the thickness. Then the dynamic wind loading, that is very important. Actually, the along wind, across wind, and interference effect, if it is there, those things we have to consider. Then in some cases, depending upon the location, most of the cases, the wind is going to govern, but still this earthquake loading also has to be considered. So these are the dominant action. And as I said that, like earlier, it was IS 4998 1992, and it was having two parts, one related to the wind and another related to the design criteria. But now, like the design and the wind, everything that is combined to this IS 4998 2015, but it still refers to IS 875, Part 1 for the dead load, and Part 2 for the imposed load, Part 3 for the wind load, and IS 1893 Part 4 for the seismic action, and IS 456, that is the basic design code for design and detailing. And internationally, we have CSIR Model Code 2011. As I said earlier, it has many parts. One is for freestanding concrete chimney, one is for steel chimney, then the concrete chimney with steel liner or FRP liner, etc. In fact, FRP is a latest addition. Then ACI 307, again, it is 2023 version has come up. And in fact, IS 4998, earlier version was 2008, and even the dynamic action, the crosswind forces, computation, etc., we have referred to this ACI 307. Then Eurocode, the 2025 version, that is EN 13084, that again refers to some of the earlier Euro codes, that is EN 1998 Part 64 seismic action and EN 19114 for the wind action, like that. So there are various international standards, because the even if you in some countries some of these codes are popular, but still I think people do with even in our country with IS 4998 again can have a check with CSIR Model Code. That sort of principle can be followed also. So with respect to the IS 4998, basically that is for the circular industrial chimneys. Actually, you can have chimneys of other cross sections also, but if you are going for other cross sections, then the internal testing will have to be done. So only this is applicable for the circular industrial chimneys. And here the load assessment and structural design requirements, they are combined. As I said that in 1992, they were in different parts. Then the ultimate limit state, basically the stability, flexure, compression, combined axial and bending, then the foundation failure, etc. we have to check, and serviceability checks are there with respect to crack width, deflection, durability, and vibration. Basically, the various aspects to be seen. So the design step starts with selection of height and diameter, then determination of dead imposed load, wind, earthquake, and thermal loads. Then, as I said, that we have to perform the dynamic analysis, pre-vibration analysis required. To perform along, calculate the axial forces, bending moment, and stresses. Design shell thickness and reinforcement. Again, like you have the vertical reinforcement and also the hoop reinforcement also. Then check serviceability and ultimate limit states, whether the criteria are met with, and design of foundation. Foundation, again, we can have either a raft pile or a pile, combined pile raft foundation. and then the reinforcement detailing and construction drawing preparation. So the input parameters basically they require, apart from the geometrical parameters, because that is governed by the environmental compliance, the flue gas temperature, gas flow rate, internal pressure, corrosion, that exposure class, then which type of lining and how the lining is held, whether it is a freestanding or it is attached one, what is the thickness of that liner, etc. Then the concrete grade, then the reinforcement grade, then definitely the soil investigation report and zone in which it is there, the wind speed zone and the earthquake zone. And design life, like 50 to 100 years, but I see that many of them, they have retired early. So I think 50-year is generally what is considered now. So with respect to the thermal and operational parameters, as I said that the flue gas temperature, that is very important, because in some cases it is 120 degree and in some process cases it is 400 degrees centigrade, because that thermal gradient will depend on what is the difference between the temperature inside and outside. So that will give the thermal gradient, and from where you can work out what is the induced thermal stress. And if it is not appropriately considered, then there can be some cracking happening. Then the flue gas composition, basically you can have either sulfur dioxide, nitrogen oxide, chlorides. Along with that, if moisture is there, then it creates an aggressive environment, and it accelerates the corrosion and the chemical attack. And because of the presence of moisture, like condensation happens at low temperature, and that is basically determinantal for the liner degradation, and also you may require some early maintenance. So that is why the chemical composition of the flue gas, that is also very important, and it controls the, how it is relevant is it controls the corrosion rate, and also the acid attack is what we have to be worried about. And the insulation efficiency, because that will reduce the shell temperature and also prevent the condensation. And as far as the environmental and dispersion design parameters, basically they are the stack height, because that will control the dilution distance, because that will help to reduce the ground level pollution concentration. And what is the exit velocity, because that will govern the plume rise and also prevents the downwash. Stack diameter and the emission rate, that will affect the concentration level. And definitely we have to meet, apart from the structural considerations, the regulatory limits, because we need to protect the public health. So the environmental compliance in India with CPCB, that is very important. So these are the dispersion design parameters. So this I'm not going into detail, but I think we need like a material, like what is the thermal conductivity of concrete, then coefficient of thermal expansion, then flue gas temperature, ambience temperature, liner thickness, liner conductivity, insulation thickness, conductivity, whether there is an air gap between these two. So what is the thickness of that? So all these things are required, because again, with the thermal analysis, there can be a proper heat transfer analysis that can also be done. So we need many of them as the input parameters. So the chimney must be designed for the dead load, basically the self-weight liner platforms, and the density you can get it from IS 875 Part 1. Imposed load can come from IS 875 Part 2. Then wind load IS 875 Part 3 and IS 4998-2015. Earthquake load, as I said, IS 1893 Part 4. Then temperature effects and construction load where applicable. You can see that in this figure, see it is the lateral force, that is the wind. So it is acting in the direction that is the along wind force, and the wind will have the turbulence. So it is the basically the buffeting force what we have to work out, which is we call it as the along wind force, which has definitely two components. One is because of the turbulence present in the approaching wind and a resonant component. Then there could be a vortex-induced vibration, that is the oscillation in the perpendicular direction, and that will cause some fluctuating lift, and that give rise to a crosswind force. So we have the RCC shell liner, then definitely the thermal flex and the these things, and also with respect to the seismic, basically it is mass into acceleration. So the seismic inertia, that also has to be considered. So these are the loads to be considered for the design. And with respect to the imposed load, I would like to say that basically this has to be considered basically for the individual structural element design. For example, you can see here there are number of platforms provided, and there may be some ladders also there. So the platform, ladders, etc. for their design basically and if some local strengthening is there required, there only you consider this imposed load. And imposed loads on internal platform and hood of multi-flue chimneys shall include appropriate load during construction, because during the construction some people will be standing with some equipments, etc. So those things to be considered. But overall design of chimney, shell and foundation, we need not have to consider the imposed load. So it is only for the local design and also for the design of these platforms, because again these platforms are at different heights. So definitely it has to be appropriately considered. Okay. Then the wind load, basically you know that wind is a random force, and that is governing the tall chimney design. So we have the along wind effect, that is the dynamic gust response method, that is the gust response factor or gust factor method that can be used to work out the along wind forces. And as I said earlier, across wind, that is the vortex excitation. It is due to the vortex excitation. And then like when they are present in a group, then there will be wind-induced interference effect on the downstream chimney because of the presence of upstream one. Then along wind and across wind moments, basically they are to be combined for the design. And apart from that, there is a circumferential wind pressure on the shell. Basically, like I will explain that. See, this is the along wind force, and because of the along wind force, it is basically mean wind velocity and the turbulence present in the wind that give rise to this along wind force, and that causes some along wind displacement also. And you can see that the alternate vortices are shed from especially at the top of the chimney, and that give rise to the across wind forces. And basically the lock-in condition happens when the vortex induced frequency, that is the shedding of vortices, the frequency of shedding of vortices, that coincides with the structural frequency or the chimney frequency. So basically the along wind, that is in the same direction as the approach wind, and across wind load, that is perpendicular to the direction of approaching wind. So across wind load, that is basically a lateral force because it is perpendicular to the wind direction, and it is caused by the vortex shedding, not by the direct pressure of the wind. So I just want to tell you that this is a chimney, then the bend shear, bending moment, etc. because of these will be there. And also like it can vibrate in different modes, because these modes are also important. So the dynamic analysis is required. And in fact, IS 4998 that gives for unlined chimneys for preliminary calculation some empirical equation for first and second mode, but for the uh, other type of chimneys, like you need the proper FEM analysis, etc. So you can see, because it's a cantilever structure, so these are the modes. So they are also important. And determination of design wind speed, I think you all know that it is obtained by where the chimney is located, what is the basic wind speed, and K1, K2, K3, K4. But here, like, we have to consider the hourly mean wind speed for the design, because we are using the gust fracture approach, and the 50-year return period that is considered. That then, like, the terrain category is considered as 2. So the topography factor and if it is a cyclonic region, then that importance factor that also has to be considered. And the design wind pressure, you know how to compute, that is PZ is 0.6 VZ square. Then the along wind force, as I said, that it has 2 components. One is the mean and one is the fluctuating one. And the fluctuating one, the component, that is because of the gust effect. And you can see that the F bar Z, that is the gust fluctuating component, and it depends on the gust response factor. And how to compute the gust response factor, I'm sure you are familiar with it, because this is like that what we have given in like in IS 875 part 3. And here, only thing important is that the structural damping, what you have to take for the along wind load, that is 0.016, that is there. And when you talk about the gust response factor, there are 2 terms there inside the square root symbol, that is B plus SE by beta. Basically, B is the background factor, that is because of the turbulence which is present in the wind, and SE by beta, basically E is the energy content available in the spectrum, and the resonance happened when the frequency of that turbulence is matching with the structural frequency. So that's why, like, you have to work out this SE by beta, and beta is the structural damping, because that damping has an effect on this. So, and the CD value, because here being the along wind force, like, you know what should be the what has to be the CD value for being a circular section, like 0.8 is what is given in IS 4998, and generally, like, this is the value used in many codes. And I want to tell you about the crosswind oscillation. Basically, when a circular structure is there, and like the wind is approaching here, and then it is going around the circular structure, then what happens is that the boundary layer is near, but it is attached to the structure itself. But in certain cases, it separates, and you can see that these vortices are shed. And you can see that that gives to like the oscillation of the structure. So the crosswind forces, that is, it is mainly because of the fluctuating lift force, this sort of oscillation is happening. And you will see here that these are some of the steel chimneys, and they have been provided with the strakes. Basically, that strake is to prevent the crosswind oscillation. In fact, IS 4998 1992 that in fact gave some discrete strakes for the concrete chimneys also. But I think the provision of the strakes in concrete chimneys, the CD value get increased, like that 0.8 that becomes 1. So you are designing it for a higher forces. So not that beneficial. So now you are not considering that strake for the concrete chimneys. So you can see that these vortices are shed, and the locked in region means it is not happening at all wind speed, but only at certain wind speed where the shedding frequency is coinciding with the structural frequency. That is why it is called the locked in region. Only at that particular region this vortex shedding is happening, and whether that what is the critical wind speed at which this vortex shedding is going to happen, that we can work out using this Strohal number. And Strohal number generally it is 0.2 for the circular structure. So the critical wind speed can be worked out if you know the frequency of the structure and the diameter of the chimney, that can be worked out. So IS 4998 also gives that to work out the critical wind speed and check whether that is below the design wind speed. That means the vortex shedding is likely to happen. And in that case, like, you have to consider the across wind forces. So why the across wind load is important is that if it is not accounted for, then it can have a lateral deflection. I have shown you this lateral deflection, that is what it can happen. And because this is going to happen at a low wind speed, so the vortex induced oscillation, that is a limited amplitude oscillation, but still it can cause fatigue, especially the fatigue damage of steel chimneys is there. And even the fatigue for concrete is there. In fact, CSIR code consider the fatigue effect also. Then it can lead to some cracking in reinforced concrete chimney, and in some cases some structural instability and failure also. Because in some cases, like, you may find that the crosswind forces are much higher than the along wind forces. So we cannot ignore the crosswind forces. Then the basis is, as I said, that it is because of the vortex shedding. Vortices are shed alternatively from each side of the chimney, and alternative forces create the fluctuating pressure. Basically, it is the fluctuating lift force that we have to consider when we have to work out what is the crosswind forces. So the lateral oscillation, that can be large, and that can create, because the resonance can happen, that is when the vortex shedding frequency matches with that of the structural frequency, large oscillation can happen at a particular wind speed. That is the lock-in phenomena. So the factors affecting the crosswind forces are higher wind speed generally increases the crosswind response. Chimney height, taller chimneys are more flexible, especially you can see that the strakes are provided at the top, maybe 1/4 or 2/3, 1/3 height of the chimney. Then the diameter of the chimney, natural frequency, structural damping is very important. If you have a higher damping, the amplitude of oscillation will get reduced, and terrain and the turbulence presence also is important. And this is what I said, that for the preliminary design, they have given a empirical formula. Only thing you have to, you should know what is the thickness of the shell at bottom, what is the thickness at the top, and the central line diameter of the shell at the bottom, what is the density of concrete, and the dynamic modulus of concrete. So from M25 to M50 grade concrete, the dynamic modulus values have been given. Also, how to compute the And the second mode frequency, that is also given, only like they are applicable for unlined chimney. So that's why like you need a proper free vibration analysis to find out what is the frequency of vibration in various modes. Then this is what I said earlier also, the critical wind speed at which vortex shedding matches with chimney's natural frequency, that is VCR, we have to find out, that is FD by ST. And in IS 4998, it says that if the VCR is between 0.5 V Z reference and 1.3 V Z reference, then like we have to, for both first and second modes, then we have to work out the crosswind loads. We cannot ignore it. Outside that, like we can, we need not consider the crosswind load. Now, this is the aerodynamic interference. You can see that this is a wind tunnel and the turntable, and these are two chimneys. But we are studying this particular chimney, which is in the downstream, because of the presence of this one. So this may be a wooden model, but this is a aeroelastic model generally made of aluminium. And the power plant structures, they are also, like you can see, simulated. And also you can see that this is a test section, and the floor of the test section, some roughness elements are kept. These roughness elements are designed such that you are able to simulate the atmospheric boundary layer inside this particular wind tunnel. And here you can see that number of chimneys are there, and even they have studied with the help of the strakes, etc. And at the base, there will be some strain gauges pasted, so that like you can work out what is the bending moment because of the wind, both along wind, across wind, etc. You can obtain from that, from the instrumentation, you can get it. So the wind-induced interference, now like how they have addressed this, like that, as I said, that the lift force, that is the across wind force, that has to be modified. So the depending upon the distance, like what value to be taken, that multiplying factor that has been given. And for chimneys, if they are not identical, because as I said that in some of the power plants, there are one tall chimney and one some short chimney which was constructed earlier may be there. And if the spacing by diameter is less than 3, then you may require a boundary layer wind tunnel on models, or like if you have some wind tunnel tests are already done for the similar arrangement, maybe you can refer to that. So this is what is given. So basically, the change in the lift force because of the presence in the other, that has to be considered. But it has not given like, except like the wind tunnel testing specification, not given like whether it can be, need not be considered. Because even in the power plant, sometimes like there are certain availability of land, restriction of land is there, because of which you have to keep them close. And also some pipes, etc., pipe connections, etc., are to be done. So you cannot space it that far to minimize the interference effect. So because of other consideration, you may have to keep it very close also. But you have to consider the across wind force, you cannot ignore it. Then the circumferential movement due to wind, that is also important, because I have shown you what happens when the circular section wind is moving around that. That will give to a non-uniform pressure distribution around the circular body, which is dependent on the Reynolds number. And that non-uniform wind pressure that can create unequal pressure distribution on the circular circumference of the shell. And because of that, section can slightly deform also. So some circumferential bending moments and hoop stresses are all developed. In fact, ovaling is one important phenomena which is to be considered for a cooling tower. Because there, when you are doing a dynamic analysis, even in the ovaling mode also you have to see. That is circumferential modes. Apart from the vertical mode, the circumferential modes are very important in the case of cooling tower. But here again, like the circumferential bending moments, they are to be considered because that can give rise to some local stresses. So the stresses are significant in concrete chimneys and steel chimneys when the shell is thin, and structural safety is compromised if the circumferential wind effects are not considered. So there is a method by which like you can work out the circumferential wind forces. So it is, but here you have to see that this PZ, which is used in the calculation of circumferential ring moment, that is the design wind pressure due to 3-second gust and not the hourly mean wind speed. Hourly mean wind speed is used for the along wind force because you are using the gust factor approach. Because depending upon the, you can say, the duration of wind, like 3-second or hourly wind speed, the value is also changing. So in this case, you have to consider the 3-second gust for the calculation of circumferential ring forces. Then the earthquake forces, basically tall chimneys, they are long period structure because they have the frequency lower than 1 and with low seismic mass participation. And IS 1893 part 4, that is what this IS 4998 refers to. But here they have given a response reduction factor of 2 and an importance factor of 1.75 that is given for the earthquake. And these are general methods which you can use, like equivalent static method, which is a simple and force-based approach method for short chimneys, and response spectrum where like you consider multiple modes and model superposition, and the dynamic effects can be considered. And if you have a very tall or chimney which is close to the near fault region, there you can go for a time history analysis. So that sort of analysis one can go. Then this is about the temperature distribution, which is very important. So here the important aspect is that what is the stress developed because of the thermal distribution. So the sigma T, the thermal stress, that is E, that is the elastic modulus of the material and coefficient of thermal expansion, and delta T, that is the difference between the inner and outer temperature. So, but you have to understand that this particular relation that is valid for a fully restrained homogeneous material subjected to a uniform temperature range, and it assumes that the thermal expansion is completely prevented and no stress redistribution occurs within the section. So this is the you can say assumption on which we are working out this, but this is the method which even the ACI and other they have specified, but they say that like if you want, you can go for a heat transfer analysis also. So the thermal loads, when we talk about, basically we know that the chimneys operate with hot flue gases. So high internal gas temperature is there with relative to the ambient temperature. So radial temperature gradient, the wall thickness generates, and non-uniform vertical and circumferential temperature distributions are there. So we have to consider during the structural analysis, what is the uniform temperature rise that is causing global expansion, and the axial thermal strain, thermal gradient between the hot inner face and the cooler outer face, which is inducing the bending, then restraint force, which is there at the base and supports if the thermal expansion is prevented, then transient thermal loads, because that may happen that when you are starting up or when you are doing the shutdown or maybe some emergency trips. So all these 4 cases are to be seen. And for chimneys with liner, differential thermal movement between the liner and outer shell, that also has to be considered. So I'm just giving a glimpse of what is given in ACI code 23. This is for the thermal design of the concrete chimney that is carried out, first determining the temperature distribution through the chimney wall and then calculating the stress. So it has given appendices, that is appendix C for thermal temperature gradient and appendix D for the stresses. And basically the operating temperatures, they are to be established. As we discussed earlier, what are the input parameters? The flue gas temperature, ambient air temperature, maximum and minimum operating condition, and if there is some startup or shutdown conditions are there, those things are to be seen. Then we have to see what the thermal temperature gradient, that will depend on how we are constructing the chimney, whether the chimney is unlined or lining is bonded with the concrete, or insulation completely filling the annular space, or unventilated air gap or ventilated air gap. So for all these conditions, basically this ACI 307 that provides separate procedure. So these things are covered here. That's why I try to give a glimpse of this particular one. And the delta T, which we have to calculate, that is key inside my outside. And also, like, you have some equations given in appendix C, depending upon the type of the liner or insulation, etc. Or they say that the detailed heat transfer analysis can also be performed. Then step 4 is the calculate thermal stresses. Again, appendix D gives, again, vertical thermal stresses. And as I said, that the circumferential thermal stresses, they are also important. And you have to evaluate what is the stress in concrete and reinforcing steel also. And in this case, like, you have to modify the material strength. So the strength reduction factor, that is also given while considering the thermal effect. So combine the thermal effect with structural loads. Basically, we have to do dead load plus thermal, dead load plus wind plus thermal, earthquake with thermal, like that. And then you do the serviceability check as well as the strength check that has to be done. Now, if you just see what is given in IS 4998, they are basically the methods are aligned. So you can see the dead load, they have given the partial safety factor of 1.4, and dead load plus wind load plus temperature, again they have given, and wind load they have given 1.6. That 1.6 is for the along wind loads. And if we are combining along wind and across wind together, then they say that you can use a factor of 1.4. Then dead load plus earthquake load plus thermal, or wind load plus thermal. Basically, the wind, we discussed that the circumferential stresses are important for design, even temperature. Because of that, the circumferential stresses are generated. So wind load and thermal load, both together, we have to consider for the circumferential ring moment, and the values, the partial safety factors are given. So this is how the load combinations are to be considered. And as I said, that M25 to M50, that is the grade of concrete which they have specified, but minimum is M25, and reinforcement and concrete detailing, basically IS 456 is to be followed. And if you see that even the ACI code also, the longitudinal reinforcement, circumferential, then a combined axial force and bending moment to be considered, cracking requirement to be checked, minimum reinforcement provisions, those things are given in ACI also. And as I said, that the liner design, that is very critical for the performance of the chimney. And you can have either single flue chimney or multiple flue chimney, and there could be metallic liner or refractory liner, and even The liner may be independent or it may be a supported liner system. So there can be a lot of options available. Independent liners, they are preferred for tall chimneys because they reduce the stress transfer to the outer shell, whereas supported liners may introduce additional interaction effect. Then the thermal expansion difference between the liner and shell require careful detailing through the expansion joints or slip connections to prevent the stress accumulation and structural damage. Actually, if the liner design is not appropriately done, then that can cause cracking, support failure, and also long-term deterioration. So liner design is also very important. So the liner design selection, that is what material to be used for liner, and the detailing that has to be integrated with thermal, structural, and operational consideration to ensure a reliable performance. So the serviceability check, I'm just giving what is given in IS 4998, the top lateral deflection, they said H by 500. Crack control, they are following IS 456. So depending upon the environment, 0.3 or 0.2 or 0.1, like that. Stress check for steel and concrete within the specified limits, they are specified. And foundation performance, basically it should not have some settlement, etc. So these checks basically help that the chimney remains functional, durable, and stable during the service life under normal operating condition. And when we talk about the performance, even I have seen in some of the papers in Poland, like after 1 year, the chimney is developing cracks. So basically you can see that the cracks happening, like they are vertical cracks, and they say it is a normal crack because that is not a very wide crack, but there are certain cracks which are very wide that they are called the separating crack. Basically, where the hoop reinforcement or the circumferential reinforcement is insufficient, there the separating cracks happen. That is that outer shell, and also there could be some buckling that has happened that can also lead to this sort of wide crack, and basically the wind load resisting capacity that gets reduced if the wide cracks are happening. You can see here some spalling, cracking, etc. happening, and because basically either you have the slip form construction or jump construction, and if the construction joints are not properly designed and detailed, like you can see that the cracks happening at the location of construction joint and the condensed material that is oozing out of that particular joint. So you can have the cracks because of usage of poor quality material, or poor quality control, crack caused by the temperature, that if it is not properly assessed, even the liner design and liner material, that is also important. Cracks caused by improper technology of construction, because slip form, that is a continuous movement, and the jump form, that both are the construction tolerances, which is specified in IS 4998, that also needs to be seen, because the construction with that again, like some cracks, etc., can develop, then it can be creep, shrinkage, etc. So vertical is important in fertilizer plant or the chimneys which are there in the coastal region. Lining failure I have explained because of the heat transfer or concrete degradation. Corrosion of steel which is embedded in concrete. And the remedies can be like you use a higher grade concrete which is more low permeability, because concrete has interconnected pores. So low permeability mix and adequate cover and protective coating and periodic inspection. In fact, because of the height, the access to the chimney, that is an issue to see, do the inspection. But now with the modern technology available, they can be used for the inspection. Then the foundation design, basically, you can have either raft or pile raft foundation. Again, that should resist vertical load, overturning moment, lateral loads, while limiting the differential settlement. Actually, that is very important. The differential settlement should not happen, and the tilt also that needs to be seen. So if you see a comparison of what is given in ACI, Eurocode and CSIR, basically wind, they have like a quasi-static and some checks are there, and as I said earlier, EN that refers to that EN 199114. This CSIR also follows mean plus gust equivalent, like what we are doing. Then a crosswind, basically they call it as vortex induced vibration, and it has to be definitely project specific because it depends on what is the frequency of the chimney and diameter of the chimney, etc. And Eurocode has given some empirical option. We have also given empirical option, and then in the CSIR, they consider the negative aerodynamic damping and also the bandwidth, etc. Then seismic elastic spectrum method for ACI and EN 998, I said that part 6 to be referred. Then CSIR, they give limit state plus ductility requirement. Then thermal, some basic guidance is given in ACI. I have explained that. Then this EN also just given, and CSIR, they have detailed liner and shell rules, because depending upon the liner, whether it is FRP or steel, along with the concrete shell, they have given everything separately. And ACI has a deterministic approach, but the reliability targets are given in Eurocode, and also partial safety factor given. Then the fatigue is also considered in CSIR. So you can see the design method like limit state method, and the dynamic analysis is required, and CSIR has some advanced procedure also given, and crack control that is given, and temperature also, like details are included. And these are about the load factor. In fact, like if you see that our IS 4998, that is also very close to these ACI 307, and the concrete and steel, like here they have given a strain lower than what is given in CSIR and ACI. So the factors are almost the same range. So in to conclude, basically the wind governs most of the tall chimney designs, and a long wind, a crosswind, and wind-induced interference to be considered. Apart from that, the circumferential wind effect to be considered, that is very important because of the non-uniform pressure distribution around the circular chimney. Then dynamic analysis is essential because it's a wind sensitive structure, both for like thermal, both for earthquake as well as wind, because if it is a tall structure, you may have to go for response spectrum method, or like you have to go for time history method. So the dynamic analysis becomes essential, and also with respect to wind, like for a long wind and a crosswind, also you need that. Then temperature effects have significant and needs due consideration. And we have seen that the cracks happening, and the wider cracks, that should not happen. So this IS 4998, basically that aligns with the limit state design principles and given in other code of practices also. Serviceability and durability, that they are also equally important as the strength check also. But here, apart from the structural aspects, the environmental regulatory compliance, that is also very essential. So these are the aspects, and I hope that I have given you an introduction, you can say, to the chimney design. But I'm sure that if you start doing the design, definitely it will help you. So thank you very much for your patience hearing. And if you have any questions, I'll be happy to answer that.
Thank you, madam, for excellent presentation. Before I ask the persons to ask you a few questions,
Yes.
I have just one or two things in mind. One
Yes.
is that for tall chimneys, this instrumentation while during construction or post-construction, I mean, you have something in mind for structural monitoring?
I think I have not considered that aspect right now, but I think something is possible, but I will look into it, sir. How it can be done, because of the thermal effect, like the sensors, etc., should withstand those things. So maybe some non-contact measurements is possible. So I'm sure there are certain aspects. Field monitoring is there for chimneys, but what type of sensors to be used, they are not the one which are used in other structures.
Second one is for tall chimneys, what about the enabling structures? Because that is also equally important. I mean, the type of scaffolding that we need to put.
So that is what I said. There are two type of this thing. They have to be properly designed, the slip form or the jump form. So those things have to be properly designed, sir.
Thank you, Vikas. Please ask those questions which are with you.
Yes, sir. Yes, sir. We have received. Yes, sir. Yes, we have received many questions in the Q&A. Ma'am, first question is by Mr. Dr. Satish Kumar Sharma. What are special cements and admixtures for RCC chimneys?
Special cements and
admixtures.
Yeah, I said that should have a low permeability mix, but what can be, and the grade can be M40 or M50 like that. But as per what is given in IS 456, like that can be used to achieve these grades and low permeable concrete.
Thank you, ma'am. Mr. Mohammad Adam asked, is there any relation between height of chimneys and base diameter?
Yes, that height to diameter ratio, that is quite important. Yes.
Ma'am, Mr. Gaurav asked, crosswind happen in circular reaction only.
What is that?
Or crosswind.
Yeah.
Happen in circular reaction only, or other shapes also?
Actually, a crosswind oscillation that can happen in other shapes also, but in chimneys, that is happening, which we are considering here. But if you see, even in a bridge deck, there also in the vertical direction that can happen. So it can happen in other structures also. Yes.
Thank you, Mr. Raghava Gopal Setti asked, are there specific advantages of multi-flue chimneys in comparison to the regular chimneys? How do
definitely.
How do we decide? How do we decide how many flues to be provided within a chimney?
Actually, nowadays, this Central Electricity Authority, as I said, that they are fixed the height 275 meters. Earlier, they were of different heights, and they are providing with some two flues. Actually, it all depends on how many boiler units are there. So that is connected to that. So it all depends on what the other configurations, etc., that are to be considered. And when you have large number of chimneys, then more interference problem and etc. So it is better to have a single structural shell with multi-flues, that will be definitely advantageous, because it has to be seen with respect to the project where they are designing the chimney.
Thank you, ma'am. His another question is, how do we ensure safety against resonance? Are resonance-related failures reported?
As I said that the resonance is important, and earlier the strakes were provided. Even for steel chimneys, like you provide the strakes. Nowadays, for concrete chimneys, they are not providing strake because that will enhance the along wind forces, because the CD value increases. But I found that there are certain because increasing the damping also, that will reduce the amplitude. So whether some dampers can be provided, such things are also there. So probably like the resonance, like you cannot eliminate it, because the vortex shedding is likely to happen at a lower, at a wind speed which is lower than the design wind speed. So the cannot eliminate it, but definitely it can be controlled with the design. Definitely, yes.
Yeah, ma'am. He again asked, you mentioned non-circular chimneys. Why do we provide non-circular shapes? Is it only by personal choice?
That shapes are there, like some square or hexagonal, etc. But generally, circular chimneys are provided because that will have a lower drag coefficient compared to the other shapes, and also the slip form construction, etc. The construction can be much better controlled with a circular form.
Thank you, ma'am. Ms. Janvi Patil asked, what are the primary parameters responsible for concrete chimney failures that an engineer must keep in check, and what key factors should be prioritized during design to prevent them?
I think I explained many of them. One is with respect to the wind action, the circumferential wind forces to be considered, and the across wind force, if it is to be considered, that to be taken into account. Then the thermal gradients, those things, and the design detailing of the liner, etc. So all those aspects are important, and like they have to be considered.
Mr. Tejas Kulkarni asked, if chimneys are closely spaced, the across wind effect increases. So when designing an isolated chimney, do we consider additional chimneys to come up around in the future?
Yes, definitely. I have done wind tunnel test in 90s, and that designer, they gave what is the future plan of the chimneys. So I consider all of them for the wind tunnel testing. So if you, because of our limited funds, probably one chimney may be coming now, maybe one coming after few years. So definitely those things, future expansions, if they are there, they have to be considered. And if some nearby cooling towers are there, that also to be considered. And other power plant structures also to be considered.
Mr. Ramaraj asked, how to calculate the thermal load?
Yeah, I explained them, and you can refer to ACI or like IS 4998, etc. for that purpose.
Thank you, ma'am. Subhajit asked, can we use the frequency calculated from any analytical software?
Yeah, analytical software you can use. Only thing, like you have to model the structure appropriately. Not that it is just a, you can say a cantilever beam. Because in 90s, these commercial softwares were not available. So I developed a software using as the truncated cone elements were used, because the shell has to be properly, the hollow shell section has to be properly simulated. But nowadays, like you have number of commercial software available. And as I said that how the liner is there, whether it is independent or dependent, all those things to be considered when you are doing the dynamic analysis. and in many cases like what type of foundation, soil structure interaction, if it is to be considered, those things are to be included, definitely. Yeah.
Mr. Hemant Kaur asked, based on your experience with the design of tall reinforced concrete chimneys around 275 meter in height, how do the wind-induced base shear and overturning movement obtained from high-frequency force balance or aeroelastic wind tunnel testing typically compare with values calculated using design codes? He continues that, for example, if wind tunnel testing predicts along wind and across wind base shear and overturning movements that are approximately 75% of the code-based values, is such a reduction commonly observed in practice? Also, two major design codes such as ASC 7, Eurocode or IS 4998 impose any limits on the extent to which design wind loads may be reduced based on validated wind tunnel test results.
Very difficult to answer right now. Maybe I can check and get back to. Okay.
Yeah, thank you, ma'am.
That is a practical question.
Mr. Rava.
But definitely we do compute both analytical method as well as wind tunnel studies to get these moments along and across wind. But I am not remembering now like how those values were, whether they were matching or how they were apart and all such things. Definitely you can check and come back.
Thank you, Mr. Raghava asked, what are ventilated and unventilated air gaps?
Ventilated
and unventilated.
The space between the shell and the liner, whether it is ventilated or unventilated. Yeah.
Mr. Kuwar asked, if an existing chimney was designed without considering the future chimney of comparable geometry, how to ensure the existing chimney remains safe?
What is that? Can you repeat?
If an existing chimney was designed without considering the future chimney of comparable geometry, how to ensure the existing chimney remains safe?
I think the design will have to be checked with respect to the presence, whether it is in the upstream or downstream, and what is the frequency value of the existing chimney. If it is more than one, then probably you don't have to worry about that. But if it is less than one, definitely the design will have to be checked. And as I said that for retrofitting purposes now the pre-stressing etc. are also done. So some measures will have to be done for that to make it safe.
Thank you, ma'am. Mr. Chandrasekhar asked, in my experience with slip form concrete construction, one of the major contributors to cracking in reinforced concrete chimneys is not only thermal effects, but also concrete quality during continuous placement.
Yeah, definitely. Yeah.
Since slip form operations require uninterrupted concreting, transit mixers are sometimes retained beyond the designed concrete retention time, resulting in slump, loss, delayed setting, reduced early green strength, and in some cases, the addition of water or admixtures at site. How do you control these issues in practice, and what quality assurance measures do you implement to ensure that prolonged transit mixer retention and continuous slip form concreting do not lead to long-term cracking or durability problems?
I think you have rightly identified the problem. Definitely the construction practices, and these are the problems not only for chimney but for other structures also. And I think being at site, you should be able to manage it. That is what I would say. But I think you know the problem, so you can find out the solution also. Yeah.
Well, Mr. Rakesh asked, for a single flue chimney, if lining is supported on core bells, is the H/500 deflection criteria critical? What is permissible deflection as per ACI?
I don't remember the value, but I think this H/500, that is the deflection at the tip of the chimney. Because you have to give what is the details of the chimney, and then only like you can say it.
Thank you, ma'am. Mr. Dhruvin asked, is it advisable to change grade of concrete as we go higher in height in very tall chimneys?
I think there will be difficulty with the quality control at site. So it is better to go with one grade of concrete.
Thank you, ma'am. Mr. Uma Maheshwar asked, what should be the recommended minimum depth of foundation with reference to the chimney's height?
I think that depends on soil parameters. That's why I said that soil investigation report is important.
Vikas, let's wind up.
Okay, sir. I'll take just the last question. Dr. Rajiv asked, parabolic chimney outer surface is commonly used in design. Please explain its benefit and codal provisions.
What is that?
Parabolic chimney outer surface is commonly used in design. Please explain its benefit and codal provisions.
Understand the question. Look into it. You can send me the question.
Okay, thank you.
I think let's now conclude, Vikas.
Yes.
Madam, excellent presentation on the design principles and performance of concrete chimneys, where you told us the wind governs, the dynamic analysis, the temperature effect, soil structure interaction, specifically important code use of IS 4998 2015, regulatory compliance, then detailing. So all those things are really important. We have to do the right design and then good construction practice. So these are very important things. And thank you on my behalf and behalf of Institute Structural Engineers that you have been able to devote so much time, and I'm sure the listeners would definitely get benefit. Thank you once again, madam.
Thank you all participants for your interest, and happy that like you are doing a lot of design and construction, and I'll be happy to interact with you, and will try to answer your questions which I have not been able to do it today. Thank you very much.
So with that, let's conclude the session.
Thank you, ma'am. Thank you.
Thank you. Thank you.
Thank you.